Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore multimodal retrieval augmented generation. That's also called multimodal RAG in short. It's a very famous use case nowadays when it comes to generative AI, where people want to work with multimodalities, nature of data. You have images, videos which have different dimensions, modalities, and you also have audios. Audio is fairly easy to work. I don't count audio to be used in the same bracket because you have the transcription, you can do a lot of things with it. Our focus will be on to see how we can look at tables, images, or in near future videos and query that knowledge base and how to retrieve information from these modalities when you talk about the different data. Now, so far we have been on my channel, at least we have been working with, I have more than 25 videos of RAG of both open source and closed source stack. The next three videos will be focusing on multimodal RAG end to end. In this video, we'll use closed source stack, completely GPT-X model. You can also replace that with Gemini, but I'm not a big fan of Google's model, so I'm going to rely on GPT-X model in this video. The next video will be completely open source. We'll use Lava in the next video as a large vision model or a multimodal LLM. So there'll be two videos. One that we're gonna do in this, we're gonna develop an application, a fast API based app where you can query your multimodal data. That's the one thing. In the next video, we'll use Lava. Most of the things will remain same, the underlying principles. We'll do a bit of changes on the pre-processing, post-processing, and also with the large vision model. The third video will be on deployment on AWS through EC2. That's the three videos. So uh, now, why this is important? Because so far we have been only looking at the text part of a PDF or a document or a text file or whatever, markdown, whatever format that you deal with. Now, imagine if you have images. You were talking about. I'll give you an example of a couple of use cases. We're talking about your electronics product. Okay, you have people query about give me an phone of range between 20 to 25,000 having 16 GB of RAM, blah blah blah. How will you also return the image with it? Not only, okay, this is the Amazon, this is the Samsung phone, or this is the OnePlus phone that you can buy, but also the images that you have in your product guide or product uh, manual that you have. So this is one of the use cases. There are n number of other use cases. So we're gonna use a few things in these videos. We'll use unstructured library first to see how we can deal with this kind of data. Then we'll take a approach that I will discuss when I'm writing the code, and we'll first do it in Colab, and then we'll build the app. Okay. Let me first show you quickly that what's going to be the end product. So it will also motivate you to watch the complete video. So let me show you. So if you look at here on my screen, I have something called multimodal RAG app. Okay. It's a fast API based app, so it's a microservices driven app. You can also, if you do localhost 8000 slash docs, it will take you to the Swagger UI where you can see the specification. We have we have two endpoints. One is get, which is for index.html. The other is post method because we wanna upload some, like you are doing a post request here, you're asking questions, and then you get the answers of it. So you can also try it out here. If you just need an API endpoint to integrate in your existing application, you can also do that. But I am more interested to show you in an app, so it can become your project. If you are working as an intern, if you want to do an internship, you are working as a final year college project, or if you want to build a proof of concept at your workplace to show the capabilities of multimodal RAG application. This, you can just take this code basis to this entire app, make a bit of changes on the backend with your data and stuff, and then you are okay to go ahead with. This is not a chatbot at this moment. This is more of a search that we have built. But it's easier to build chatbot with it. You can just add a few lines of code to have it a memory and stuff. Now, if you look at here, I'm asked a question: what is gingivitis? Now, why I'm asking this question? Because I have taken a different use case. Let me show you that. This is the source data that I have taken. You can see it's a PDF file. It says canine periodontal disease, PD, for canine. Okay, so it's for canine. Now we have, it's by United States Department of Agriculture. We're talking about a particular disease. It says what is PD? Inflammation of tissues and bone that surround and support the teeth due to a bacterial infection. PD is sometimes referred to as a dental disease. Okay, so this is related to a dog. Okay, so we're talking about pets here. So this is mainly relevant for the vet doctors, veterinary doctors that we have. That will be relevant for them. Now imagine if you have n number of PDFs like this, you have n number of documents. You can see it also contains images, and that's my focus. Like if I ask a question, what is gingivitis? It should not only return the answer like redness and inflammation at the gum line. It should give me the image as well to explain to the end user this is what gingivitis is. So I hope you now understood what I'm talking. I'm saying that if people ask what is severe PD, which is on the right hand side here, it says note the missing teeth, tartar and gingivitis. It should return with this image, not only the text part of it. And that's what we're gonna achieve in this video. So let me ask this question. What is gingivitis? And I'm gonna ask, once I ask the question, it will return the answer and also the relevant image that you will see. And this is how it looks like, a very beautiful image. I also think it has dark and light, but you can make some changes. I'm not a front end guy, by the way, but if you look at here, it says what is gingivitis. So gingivitis is a type of gum disease characterized by inflammation of the gums. It is typically caused by a buildup of plaque, sticky deposit, blah blah blah, and you get the output here in the left hand side. But on the right hand side, you get the exact image that you have in the PDF. You can see what is gingivitis, and that is why it's so important. Okay, now because you are working on multimodal RAG application, it's not only on the textual data, you can also return tables. We'll see how we can do that. We can return images, you can return text. So that's the end goal. Once you complete this video, you will have an app that can do this that you are currently seeing on the screen. Now we're gonna use unstructured. We are going to use a vector store. We're gonna probably use Chroma or Fast. You are okay to use Weaviate, Qrant, Milvus as well, depending on what kind of services you use. And we are going to use GPT-X model 3.5, vision, whatever. We'll see that they will work in tandem. And that's it. We're going to use LangChain as an orchestration framework. So let's get started and build this application, multimodal RAG app, in this video with closed source, in the next video with open source stack. Recording is already done, guys, by the way. So let's start building this application. All right, so to develop the RAG pipeline, basically we're gonna use Google Colab. Okay, we will write all of our code in Colab, and then we'll create a vector store. We'll download that vector store and build the FastAPI app. I'll tell you why. Uh, the backbone of this entire pipeline is a library called unstructured, having a pathetic documentation but a great library. Now, unstructured has a lot of issues when you work with Windows, by the way, not a library to work on Windows. Okay, it's a great library to work on a Linux distro, for example, Ubuntu. And many of you have faced this. I know many of you told me that I'm getting this error, I'm not able to install. This is the partition PDF is not working. I get popular error. I get Ghost script error and whatnot. Right? I will explain that each of those things. Now we're gonna develop the pipeline here and gonna use the persistent persistent vector store in a fast API application. So I'll show you how it works end to end. Now, if you are on a Linux distro, you need to install this Tesseract OCR libtesseract popular utils. Now, unstructured has two different backends that you can work with. So if you don't know unstructured, it's a library that helps you work with granular data. Okay, or data which having a lot of granularity in a hierarchy, like you have tables, you have images, you have unstructured data and whatnot, right? Also, now how you can use unstructured library to basically extract and parse those data. That's why we use unstructured, a very powerful library, has an integration with LangChain as well. Now, uh, it uses two different backends. One is Ghost script and the other is popular utils. And that's why we are gonna use popular utils in this one. And that's why I'm installing Tesseract that basically helps you with the optical character recognition, because we're going to use something which will get us the bounding boxes of the images through an YOLO model. I will show you. So Tesseract is there, and then libtesseract because we are on Ubuntu machine, and then popular utils that is going to act as a backend for unstructured. So let's install this. So it will take a bit of time to install. But if you are on Ubuntu, you have to download Tesseract and keep it in your path. You have to go to environmental variable, set the path, because you have to use Tesseract from there. You can keep this in a local disk C or wherever, somewhere. Depends what kind of machine you are working on. Now I have installed this. So let's come down. Now, the next thing is I'm going to still rely on the legacy version of LangChain, but you can also use the current update of LangChain version 0.1, where they have come up with three different components. One is called LangChain Core, which contains all the chains and whatnot. The other thing is LangChain Community. All the open source libraries are within LangChain Community, which has been created by community, like PyPDF, for example. And the other one is langchain underscore OpenAI, because I'm gonna use OpenAI. So they have created different classes for closed source product or services that we see, like Anthropic and whatnot, right? Now, pip install langchain. I'm going to use unstructured. I'm saying all docs. You can also download in bits and pieces, but I'm going to go with all docs. I'm going to use pydantic, that helps you with validations and stuff. I have OpenAI. Probably will use fast. You can also use ChromaDB, Weaviate, whatever. And I need TikToken, because we're going to work with OpenAI. And then we have OpenCV Python. Let's install this. Once you install, you have to restart the kernel. Okay, you have to go and restart from runtime. So you have to restart the runtime. So it will take a bit of time. Now you can see that I already have uploaded the PDF here. So you can also keep it in your drive if you're working on Google Colab. If you are locally, you can also do that. Now let me just, better to work locally if you have an Ubuntu machine. That's easier. Now I'm on Windows, as you can see. So the next thing is the imports. Just to save some time, I've created a lot of gist that I'm gonna go do a copy paste, but I will explain that these are that not that relevant, but I'll explain. If you look at here, we're gonna need a few things. The first is base 64. Why we are using base 64? We'll see that it will help us get, because we have to use the encode and decode from base 64, because we get a base 64 string there. So we have to convert that so we can get the image, right, for the decoding purpose, because GPT-4 takes a base 64 string over there. Now, okay, you can see restart session. So we have to restart. So this is all variables will be lost. It's okay. Now I'm restarting that. Once you restart, you can see on the right hand side top in Google Colab, it says restarting. So now you can see it has restarted. And now let's import all of this. As I said that I'm already using LangChain legacy. You can also use the newest version. If you are using newest version, you cannot get it from chat model. So you have to get it from langchain dot underscore OpenAI, and then you import like that. Not embeddings. Langchain underscore langchain dot community, and then you get it from there. Langchain core dot chains, then you get it from there. Something like that. Now langchain community dot vector store import file. So there's a bit difference. Go through the documentation to find out that. Now I have imported successfully. Now, once you import that successfully, what you're gonna do next is we're gonna get the OpenAI key. So let's get the OpenAI key. Now, there are few ways you can get OpenAI key. The one way is to uh, directly define it here, create an env file also, or you can if they already have something called secrets. Now, if I go to secrets, you can see I already have set my OpenAI API key here in the secrets. You can see how I have defined the name of that particular constant, which is OpenAI underscore API underscore key, all in caps, and then I give the value over here in the value that you will get it from OpenAI dashboard. Now, once you have done that, now come back here and let's write that from google.colab import. You just import the user data. So this is what you're going to import, and then OpenAI underscore API underscore key equals, and then you give user data dot get. And the way you have defined here in the secrets, you just have to write it over here. So OpenAI underscore API key. Now it will be okay to work with the API keys. Now we have heard about API keys. Let's move to get the elements. Now, when you use unstructured, they have different elements that you have can extract. I will explain that. So let me first write it. Now let's call it raw PDF elements. And I'm going to use, if you see here, I have used something called partition PDF. Okay, that's a module in unstructured. So let's use that. So I'm going to do partition. So let me just write it over. You can see it says define partition PDF. So it's a function within unstructured library, and I'm going to use that partition PDF. And inside that, I will pass a lot of parameters. You can see first is the file name. So let's pass a file name. It's a string value. Come here, copy the path. So let's copy path. Now, once you have copied the path, you can see you can pass n number of other things. The next is extract images. So I'm going to say extract images in PDF. It's a Boolean value. So extract image in PDF, and I'll say, okay, just do that because we need images. So true, extract images in PDF. Then info table, that has a other parameter called info table is structured. Yes, let's do inference. The table is structured. It's all Boolean value. Then chunking strategy. So it also has a chunking strategy that you can define. So let me just say chunking strategy, and I will say by title. You can do by header, by title, by subheader, whatnot, right? So let's keep it by title. It's again, see, there is no thumb rule that you have to use what I am using. It's again a very much trial and error experimentation and depends on what kind of documents you have at your disposal. And you have to, look at the document closely and, use your experience to when you have worked with natural language and stuff. And then you have to decide that how should you create a, chunks of your data or document that you have. Now, chunking is done. The max characters, okay, you can see it will show me max character. It's not showing me, so now it will show me. Oh, this is strange. Max characters, and then it goes 4,000. So let's keep it a bit higher. Just give me a minute. Now you can see we have max characters, and the next is new after n characters. You have used, if you have used LangChain recursive text splitter, recursive character text splitter, you will see these are in different terminologies like chunk size, chunk overlap, and whatnot. New after n chars, and let's keep it like 35, something like, okay, when we have 4,000, let's keep it like this, new, and then combine. Oh, it's not showing me. Combine text under n characters. So n chars, and then it goes like, for example, half of what you have your max character. So let's keep it 2,000. And then extract, you have to define where should you keep the images that you have extracted. So extract image block output directory. Now once you, for example, if you have a PDF which has 20 images and unstructured gets all the 20 images from it, where will you keep that 20 images is something that you define. So it's a path of that. So let's define after this an output path, or you can directly define it, but let me, maybe we need some time later. Output path equals, and I'm going to just do create an images folder in this runtime. So it will create a images folder in runtime, and I'm just going to pass here. So output path. So let me just write it. Oh, excuse me. Output path. Now this is what we have defined. We are using partition PDF file name, and we say extract images in PDF, true, info table is structured true, chunking strategy by title, max characters as 4,000, new after n characters as 3,800, a bit lesser than what you have kept as max characters, and then combine text under n chars. Now I think we are okay with it. Now let's run this and see. It says name output path is not defined. I think I didn't run it. Okay, I think now I have run it. Now let's do this. It will take a bit of time, so let me pause the video and come back because you have to download a model, and I'll show you that. As you can see, the images have been downloaded in this images folder. Now what we have done here, if you look at closely, we have extracted images from the PDF and we have saved that in that images folder on the runtime. That's what we have done first. Now how have we done it, and how does unstructured does it? Simple. First has to detect the images inside a document, can be a PDF, and for that object detection model can be also used. And if you look at here, it's using ONNX model, ONNX model, that basically helps you, runs a lot of advantages of ONNX, by the way. Okay, on compute limitations, if you have compute limitations, how you can run an object detection model, compressed model with a very smaller size and whatnot. If you look at here, it's uses YOLO. Okay, .onux had downloaded the model of having size 217 million, and then couple of shape tensors. Okay, from now it identifies the bounding boxes wherever you find the images, and then extract that image and save that wherever you have given the path. Now that's the beauty of unstructured, to get the images out of a PDF. Now if you look at here, okay, this is the images that we have got. Fantastic, I loved it. Now if you see this USDA, all the images that you will have, that you can get it, the logos and whatnot. If you look at this, I got the gingivitis image, and that's the question we asked when I started the video. If you look at this, this is something, Tata or whatever they call it, looks bad a bit, but yeah. Now, once you have the images, once you have the text, PDF, and whatnot, how can you basically do this now next? What's next? The next is to we'll take a summary approach. We'll get the summary of text and tables. Now you have tables, you have invert tables equals true, so you'll have tables. How to get the summary of those tables and text? And that's a better approach, I feel, because it has a summarization chain as well that we can use it by default, and that's the advantage. That's the one approach of doing it. The other approach is that you don't take a summary, you take the complete context or whatever extracted text that you have. Now let's see how we can get the text summaries and table summaries. For that, I'm going to do a couple of things. The first thing that I'm going to do is get a empty list for text element. So let me just do a text elements equals an empty list. We're going to append that later. The next is table elements. When you work with unstructured, it the unit is element, by the way. Now you have table elements, text element. Now also get a empty list for their summaries. So text summaries. So text summaries, and then you also give it a table summaries. So let's give it a table summaries. This is what it is. Now we have text summaries and table summaries. This becomes capital, make it small. Now let's write a summary prompt because we're going to use GPT model over here. You can also use any other smaller model as well if you want to use that. But I feel that for me, I believe that if you are don't always go on the open source if your client is not asking for that, right? Because that's again depend on what kind of problem you're working on, because no model has right now is better than GPT-4. Hands up, hands down, hands up, whatever you call it. No models. Okay, forget about the hoax that's going on that okay, Mistral XYZ model has outperformed. They outperform on a single benchmark. That's very easy to do that. If you are training an LLM, you just overtune on those data sets of the evaluations. So when you work for the real use cases, the use cases the model haven't seen in the entire training phase, that's the real benchmarking. So don't always go on that it some model has outperformed on human eval or MMLU or whatever. I'm not a big fan of those evaluation benchmarks, and even you should not consider that seriously if you're working for an enterprise. Now, GPT-4 is the best model out there in the world right now, but we'll see more open source LLM will go mainstream because that's how it has happened in the past as well. Now, if you look at summary prompt, let me create a doc string. In that, I'm going to write a summary prompt. So let me just do that. Now here I'm going to say summarize basically the elements. So summarize the following elements. Okay, so following let's have an element type because we have table and we have text. So let me just do an element underscore type thingy over here. And then I'm going to just do element. Perfect. Now this summary prompt is fine. Now we have a summary prompt. Now let's use a summary chain. So we're going to use LangChain chain for summarization because it supports that. Now summary chain, I'm going to write LLM chain. So let's do LLM chain, and then in LLM chain, I'm gonna do a few things. First is the LLM. So my LLM is nothing but the chat OpenAI. So let me just get that. Chat OpenAI, and you're gonna pass here model equals, and I'm going to use for summary, I can rely on a 3.5 turbo. And yes, many models are better than 3.5 turbo. Mistrals and some of the Mistral proprietary models and other on ELO rating if you look at there, but not with GPT-4. GPT 3.5 turbo. So let me just get it turbo and then OpenAI underscore API key to OpenAI underscore API key, and then you just give OpenAI underscore API key. And you're gonna also write a max tokens. So let's do a max underscore tokens here. So max underscore tokens, and we can keep it 124, a very standard thingy. Cool. Now we are okay with our LLM thing. Now the prompt, so prompt equals, and it goes prompt template. I'm going to use the prompt template that we have imported from on top, and in prompt template from template. So let's get from template, and in this from template I'm going to pass my summary prompt. As simple as that. You can also use LangChain expression language, LCEL. I have a detailed video on LCEL as well. If you're following the newest LangChain update 0.1, I will recommend you to use LCEL to write better chains, more readable, and also better to it is easier to scale as well. So summary prompt, so let's get that. Now summary prompt thing is done. Now let's run this. Okay, now summary chain thing is done. Now what happens next is that we're gonna write a for loop which will have two conditionals. One is for the composite element, mainly the tables in unstructured, and the other is the text. So let's write that. Now I'm gonna do for element in raw PDF element, that's the variable name that we have declared above, raw PDF elements. And now we're gonna write two if. So basically we're gonna have a conditional here. So if elif. So now let's write if composite element. So let me just write that. If composite element in element, if composite element in element. Now let's do text elements. To text elements append, text elements append, and then you're gonna write here. Uh, Generative AI is not working today in Colab. This is surprising. Otherwise, it used to show you uh, pretty fast. Now I think it's got confused. Now text element dot append. Now let's have our summary. So summary equals, and then you pass summary chain dot run, that you can run that summary chain. Now in the latest update of LangChain, the run has been depreciated. You cannot use the run there. Now here I'm gonna pass element underscore type. So let's do that, element underscore type, and your element type is nothing but the text, and then you say element e. Perfect. Now this is what my summary is, and we're just gonna append the text summaries. Okay, so text summaries dot append, and then you're gonna pass your summary variable that you have written just on top. Now my this is completed. Now I'm gonna have an elif. So elif table. So composite element is done. Now table in rep r, and then I'm gonna write e if elif table in representations of e, and then I'm going to write table underscore elements dot append, table underscore element dot append. Spelling is wrong, and then you write, so bad it's not suggesting me, append e dot text. Now I'm going to write summary again. So summary for this conditionals as well. Again summary chain dot run. At least show me now, it's so bad. Okay, summary chain dot run, and then you're going to write element type, and then you write your table. So just do a table. So table element type, and then you're going to give element. So element and e. Fine. Now table summaries dot append, and I'm going to append the table summaries. Table summaries dot append true, and then going to pass summary again here. And this will hopefully be written right. Complete element. I think let's run this now. Now this might take a bit of time. It depends on how big your PDF is, basically how big your text is that you have extracted using unstructured. If it's big, it will take more time, but now you can see for me it's done because it's only a couple of pages there. Now this is done. Now what next is that you're gonna get the image summary and pass it to basically pass it to GPT model. GPT-4 Vision Preview. For that, I already have written the code. I'll explain that just to save some time because I have created a couple of videos where I have explained the same thing again and again. So let's just get the summary thingy. Now I'm just gonna go raw, Control A, Control C, and I'll explain that what we are doing here. Now let's come back and let's just close this now. Now what we are doing here, guys, if you look at closely, we are getting the image summary, the image elements. Right now we make it an empty. Now we have an encode image because as I said in the beginning that it gets your base 64 of image when you pass it to GPT-4. You can also pass URL directly if you have an URL handy, but that's an input the GPT-4 takes. Now we have encode image, and now we have summarize image. Now if you look at the summarize image, I have a system message that I'm saying to system that you are a bot that is good at analyzing images related to dog's health because its data is related to that. So a bit of instruction as a system prompt. Now the human message that it's going to take a text, describe the content of this image, and the image URL and you are passing the encoded image you are getting from here, encode image. Now the response, because we're going to use GPT-4 vision preview, OpenAI key have been passed, max tokens, blah blah blah, and then you get response dot content. Now that's this function gives you the summarized image. Now we are saying output path, looking at the PNG, JPG, and JPEG, the image extensions, image path out from taking from output, creating for all the images that we have basically. Now that this is what this for loop does. It goes in that folder, the image output folder, takes all the images one by one, create a summary, and then append this list that we have over here, image elements and image summary. Now let's run this and see what happens. Now it will take a bit of time because you have around 10, 12 images. It has to do the processing, create it, and then again save it back. Now, after this, we're going to create a vector store. Okay, and for that, we're going to use fast. So let me just get the code again from the, because this is very easy. You have now, if you have worked with RAG, you would have done it at least n number of times. But let me just get it from here. Now I'll just again go raw, get it Control C, come over here and paste it. And I'll explain that what's happening inside this. Now what we are doing is we are saying create documents and vector store. Again, the same empty list, and we are getting the text element and text summaries. We have an unique ID for each of the image and the summaries that we have. And we are creating a metadata over here. You can see the ID, type, and original content, because in the output you also need that fetch. We have to also fetch the image as there, and then we append that. The same goes with here for the table summaries and table elements. Once for the text, once for the table summaries, table element, and then again for the image and image summary. So what we are doing here, if you look at carefully, we are creating for text, we are creating for table, we are creating for images. All goes in a vector store. Now there can be n number of approaches you can take it. You can create three different collections as well, vector stores as well that you want to do it. But that's again for you. You can try it out as a trial and error to see which one performs better. Now you can see this has ran successfully. Now once we do that, we create that, and then we are saying, okay, vector store fast from documents, 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 embedding, giving the ADA embedding model, and we're just running it. So let's run this and see what happens. Now this will again take a bit of time. You can see it has taken. Now if you come here, okay, you can also save this. Now let's save that locally so you can persist on the disk. So let me just do that. Now what I'm going to do here is vector store. This is my name of the variable that I created. I'm going to use the save local function. So do save local, and inside the save local, you're going to pass fast underscore index. So let's do that now. And now now you can see here, if you just refresh this, let me minimize the images folder. Now you can see that we have a vector store that we have created, and we're going to use the same vector store in the FastAPI app, because I'm on a window machine and I'm not going to install unstructured in my local environment. So now you can see that how you can do it on fly as well. It's very easy to do. You can just follow the same notebook, write a couple of functions and do it. But I already have the vector store, and I will just do the inference and use the vector store in my FastAPI app. Now let's try it out. What I'm going to do next is, now let's define an embedding separately. So I'm going to have an embedding function kind of a thing. So embeddings here, I'm going to pass OpenAI embedding. So let's do that. OpenAI embeddings, and I'm going to pass here OpenAI underscore API underscore key, and then I'm going to pass here OpenAI underscore API underscore key. You can also probably we should have skipped that by defining os.envar on os.get there, get env2 on top, but it's fine. Now let's load. So I'm going to call it db. So my offline task is done. Now you see this as a batch processing where you have 100 of documents, and you first create a vector store, index it, and save it wherever, whatever you are using. If you're using Elasticsearch, you can have index it and all. But you have created a vector store, a vector database offline of all of your documents. If your data is not changing every minute and hour, but you can also do it dynamically, on a periodic basis. If your data is flowing through any streaming pipeline, you can also do that. But imagine if you have 1,000 PDFs or different data, you created a vector store or vector database offline, and your task is done. You're just gonna utilize that vector database, make a connection. If it's running within a Docker or if you have on a disk, just call that. And that's what we're gonna do here. We are saying dv dot load local, because we have saved it locally. So I'm gonna do load local. So let's do that, and load local, and here I'm gonna call, not load local, fast.load local, because we want to use fast. So fast.load local, And here you just call the folder name. So our folder name is fast underscore index. Now I'm just going to call this and just pass the embedding function. So let's pass embeddings. Now once you run that, and let me just put db, it should show the fast object. Now you can see it shows the fast object. Now I'm going to write a prompt template. So let's do that. So prompt template, and in this prompt template we're going to do a few things. The first thing I'm going to do is role based prompting instructions and all of those things. You are a vet doctor and an expert in analyzing dogs health. Okay, answer the question based on the following context. Now here you can also define or declare, which can include text, images and tables. Now here you can just give the context. Now my context goes here. Now once you have the context thing done, the next is the question. So let's pass the question. So question is a variable we can define like this, and we're gonna do an input variables. Now question equal to question. Let's also say don't answer if you are not sure about, not sure, and let's do decline to answer and say excuse me, a bit of sorry, I don't have much information. So let me just do much information about it, and that's it. And then just return the helpful answer. Just return the helpful answer in as much as detailed possible, and then you just get your answer here. So let's just get the answer and let's make this. Now this is my prompt template. Now once you have written the prompt template, I'm gonna use let me just close this. Now once you written the prompt template, I'm gonna create a QA chain. So let's use QA chain. You can also use LCEL to create QA chain, but I'm gonna go with legacy LLM chain, and inside the chain I'm gonna pass LLM equals chat underscore open underscore AI. Inside this I'm gonna pass GPT-4 model for better output. So let's get GPT-4, and then you're going to pass OpenAI underscore API key equals OpenAI underscore API key. So let's do that. And then you're going to give max tokens. So max tokens equals again 124, the very standard one. And then you're going to pass your prompt thingy. Now the beauty of LCEL that they also have output parser by default, so you can use that as well. Now prompt template here, prompt template, and inside the prompt template I'm gonna do from template to, and here you just pass your prompt template thingy. So let's get prompt template and then run this. Now QHN is ready. Now I've written a function that helps you just get the output. So let's just get the function. I have just done a pre-processing kind of a thingy over there. So let me just go back to my gist and get the post-processing.py. So I'll just go raw and explain that it has metadata and stuff just to get the output, not anything else. Now, if you look at here what I'm saying, this vector store will get changed to db because now we have a db variable because we have loaded from disk. Now we have a context. So context is basically the retrieved chunk, the similar paragraphs or whatever you call it. Now, and the relevant images in a list. If there is no images, the list will be empty. If there are images, it will get returned. You always take the first image, that is has more confidence score. Now I'm saying for D in relevant docs, okay, D dot metadata type text, getting the context table, text table image, whatever is possible, and then I'm passing that in QHN.run context and question and getting the result and the relevant images. You can see over here. You can also get the table as well. Let me just run this now. Now once I run this, I'm gonna do result, and with result I'm gonna do relevant images, because that's the two things that we're gonna need in the function, and I'm gonna call answer. And inside that you're gonna ask a question. So let's ask a question like something like this, but not always that, it depends on vector store as well, how have you created. So not always you will get the result for example, if you created previously and you were getting it that time and you are not getting here, so don't say that okay, I'm not getting the answer and stuff. You sometimes you might not get as well, depending on how your vectors have been placed in the n dimensional space. Now here just let's do a result thingy. Now you can see it says gingivitis is a type of periodontal disease that primarily affect the gums, leading to inflammation, irritations, and potential infection. Fantastic answer. We got our answer. But what about the images? Now let me just do a relevant images and see if I have got any images over there. Now when I run it, if I either get an image, you can see I have got an image. I have got three images. You can see I have three different images over there that I have retrieved. Now only look at it's a list, so you can just get the element of the list. So let's get that first of that relevant images. The first one index start from 0, and you can see this is the image that we have. Now how will you run this images that you're going to use? If you are in notebook, you're going to use ipython display. So let's do that. So what I'm going to do is display. So let's do display dot display, and inside this display let's pass display dot img, display dot image, and then you just pass the, you're going to use base 64 to decode. We have to decode this base 64 string. So base 64 dot b64 something, I don't know why it's not suggesting me now. Base, yes, b64 decode, and again you're gonna pass the relevant images thingy. So relevant underscore images, and then it goes your first one. Let's run this and see if it gets you the gingivitis. You can see fantastic, we got our answer. This is the gingivitis. Now if you look at what we did here, guys, we got the text here for as a result, and then we got our relevant images separately. So text and relevant images both. Now on the front end, if you have built an application or a chat bot, you can just come you know create a create it together. Like you can create a function which will take both that we have done, text and the image, and just return to the end user about that. Now this is what we did. Now let's build this app in a locally in a fast API kind of a setup. For that, what I'm going to do is let me create a new folder. So I'm going to create a new folder. Or let me just show you that you don't have to create a new folder because you already have that created, because I've shown you the demo. I'll just walk you through because it's very easy to do that now. Now I'll explain the code. If you look at here, we have our fast index, the vector store that we have created and downloaded in this here in the folder. And we've created a virtual environment, and I'm running everything within this. Now, as I said, that you need FastAPI to work with it. So if you don't know what FastAPI is, FastAPI is a Python library. It's a framework that helps you run, build REST APIs, microservices, and whatnot, right? So there's a very scalable framework to work with. Now, Tian Golo is the creator of FastAPI. I love the guy, by the way. Now, if you look at here, we have FastAPI. All these imports are same from Google Colab. Notebook and the entire code will be available on the GitHub repository. You don't worry, you will get each and every lines of code there on repository. I'll give the link in description. Now, if you look at what we are doing, we are saying from FastAPI, input all the FastAPI thing that we need. We are gonna use Jinja 2 templates from an HTML. I'll explain that. I'm not a front-end guy, but I can explain you a bit. And then we have JSON-able encoder because we need to parse the JSON output to the front end. Now I'm initiating a fast API. App equals fast API. I'm using Jinja 2 template, and my directory name is the templates, which contains index HTML. So let's go to index HTML. Once you come to index HTML, we have a CSS styling, a lot of CSS code that we have written. Now if you come down, we have a container, because it's a bit of, we were using Bootstrap 5.3, so it's a responsive app. Now in container we have multimodal rag app, loading, blah blah blah, some CDNs to work with JavaScript kind of a thing. And then we have, if you look at here, we have few things that we are working. We are taking your we are using a fetch method. If you look at this fetch method, it takes your get. This is only where you have to make change. Now let response equals await fetch get answer. Now this get answer is nothing but the endpoint of your API that you have created in fast API. If you look at over here, get answer. Now this is the get answer thingy that we have defined here. Get answer method post and the form data, because we are collecting from a form. When you put input, that comes as a form data, and we are using a post method and using that get answer. And then we get our answer over here, blah blah blah, relevant images, and we get that, right? So very simple HTML page. Now on here, what we are doing, if you look at, we have configure course, that helps you when you are working in some production applications. Just ignore it for now. Now we have our OpenAPI key coming from the env file that I have created. You need python.env probably to work with that. We have defined our embeddings model. You can also use clip that for the next video. Now DB, we are loading it locally. You can see the fast index folder and the same prompt template that you saw on the collab, same QA chain. This is for the index.html and this is the same function that we have written. Just a couple of lines of changes I will show you. When you write the function, you get a question, which is a string and coming from a form setup, right? So a string and a form, and then using the relevant docs, and this is same till here. We are just using JSON response function in FastAPI because we have to send that to front end, and JavaScript, we are using vanilla JavaScript to get the output. Now, this is what it does. And if you run this, let me just open it here, open in terminal, and probably I'll just give me a minute. Okay, now I'm just going to do cd.venv. I already have created cd script dot slash activate and couple of cd dot dot. So let's do that, clean that, and then just do uvcon app colon app. You can also do hyphen hyphen reload, but I'm not doing it. I'm just gonna ignore all of these new warnings because it says that you're gonna use upgrade to langchain, the new version of it. And then you have to do localhost 8000. You come here, ask the same question like what is gingivitis, and I will also ask another question where you don't have image, you will get an error. What is gingivitis? Let's ask this. Now let's ask a question here also because we have this handy. Let me ask what question we can ask. Let me ask what is starter and see if we get something like here. If you ask what is starter, you can see it gives you the answer that tartar, also known as the dental calculus, is a hard, crusty deposit that forms on the teeth. It's a result of plaque, a sticky film of bacteria, because it's an infection happens in dog and whatnot. Now, it has given you the text answer. Sometimes can what happen is that it might not give you the image answer, but gives you the text, and that's something that you have to evaluate. Now, if you click on relevant images, in this case, it has given you the relevant images. Now let's see if it's the which relevant images, because you can also print out the similarity score of that. You can see this is the turtle, which is the right one, which got it the answer, right, which is fantastic. You can see we got for gingivitis. Now let's ask, tell me about tell me about tartar. So for gingivitis, we got our answer, we got the outputs, and I'm asking, tell me about tartar. Let's see if it gives you here, because that's a different vector store that I have been using just to show you the capability of it. But now I hope you got the idea, right? It's very interesting. See, fantastic answer. I loved it. You got the tartar, you got the answer. So it's whatever images we have extracted, if you ask questions related to it, it will return the answers. Okay. Now, that's all. I think that's a very interesting tutorial that I created, and I hope you now have understanding that how you can build a multimodal RAG app. And you can see it's an app, and we're gonna use the same UI, same front end screens with a open source LLM. We're gonna use Clip and Lava to do that in the next video, and we'll also deploy this in the third video on AWS EC2. So please stay tuned for the next couple of videos on multimodal RAG, and I hope you like this video. This will be available on my GitHub repository. So if you like the content, please hit the like icon, and if you haven't subscribed the channel yet, please do subscribe the channel and share the video and channel with your friends and to peer. If you have any question, thoughts, or feedbacks, please let me know in the comment box. You can also reach out to me through my social media channels. Find those information on channel banner and channel about us. That's all for this video, guys. Thank you so much for watching. See you in the next one.